Hello everyone, I am Shobik. I am continuing my PhD as a PMRF fellow in Indian Institute of Science Bangalore in Department of Biochemistry. I work on experimental biology as well as bioinformatics where I write code in Python. And here in this live session I will solve some um, example problems which will help you to do the assignments in the that was given in the week 2. Let's start with some sample problems. So our first problem was is statement looks like this: a positive integer m can be expressed as the sum of three squares if it is of the form p plus q plus r, where p, q and r is greater than or equal to 0 and p, q, r all are perfect squares. So for instance, 2 can be written as 0, which is a square number, 1 and 1, which both are square number. However, 7 cannot be expressed as sum of three squares. So the first few numbers that cannot be expressed as sum of three squares are 7, 15, 23, 28, like that. So here this theorem was proposed by Legendre. It's his three squares theorem. And so this is our question. So we have to write a Python function 3 squares m that takes an integer m as input and returns true if m can be expressed as sum of three squares. Otherwise it will be false if m is not positive also, and m should be always a positive number. So if m is not positive, then the function should return false. So how will you go by this function? So here the Lagrange's Legendre's three square theorems, and I searched in the Wikipedia. So there was one. This is the hypothesis, and so this is like the Legendre's theorem, where n is equal to x square plus y square plus z square, and there is one formula that if and only if n is not in the form of 4 to the power a 8b plus 7 for a non-negative integers of a and b, then the first three numbers can be expressed as sum of three squares. So this if so our program will see that if a number can be expressed in a 4 to the power a into 8b plus 7, this expression, if it can be expressed in this expression, then it won't fall into this particular number, right? So this is how we will write this in Python. Okay, so let's start. So our function definition will be like this. It's legend, where is this? Yeah, 3 squares m. Okay, and so how our function definition, this is our m. Now we should now we should check that if this expression gets something gets equal. So we'll say that m is equal to 4 to the power a into 8 into b plus 7, right? So now we have to check that if this number can be expressed in this, then we can do. Now one thing you can see that from here, that all the things are in so since a and b are integers, so you can say a and b are non-negative integers, correct? So non-negative integers, right? So if a and b are non-negative integers, then one thing we can say that a and b must be, so a comma b must be less than equal to m, right? That we can clearly say that it cannot be more than m, right? It should be less than equal to m. So for example, if so it should be less than equal to 10. Actually it should be I should say less than m, correct? Because everything is positive, so it should be less than m, right? Or less than n, whatever. It should be less than n, correct? So one thing is clear. Now, so how to find this now? Now, A and B can be at different from. So so A comma A comma B can be 1 0, or it can be 0 1, it can be 0 0, it can be 0 9, it can be 10 9, it can be 100 101 and 9. So we have all the possibilities of A and B, and A and so and it should be less than m, right? So we'll write the function like this. Let's say for A in range of 0 to m, we have to go in 0 to m for B in range of 0 to m. Why I am going to A and B? Because when A is equal to 0, B can be anything from 1 to m. When when A is 1, then B can be is also from 0 to m, anything. So now we are considering that 0 0 0 1 1 0 1 1 2 0. So all the combinations of A and B between 0 to m, we are considering that, correct? So now in this condition, we'll say, so this should be here. In this condition, we'll say n is equal to some number n, which is equal to 4 to the power a into 8 into b plus 7. Okay. Now we'll say that if this n is true for this particular expression, then this is not a 3 square number, right? So if at any time if m becomes equal to n, correct, the function should return us, at that moment it should return us false. Else if none of the cases it's not returning, then it should return us true, correct? Sorry, yeah. And we'll also give one more thing. If m less than 0, then of course first return false, because any non-negative integers, it's not true for any non-negative integers, as it's told, like if m is not positive, your function should give false. Okay, right. So this is how this will work, and so we'll take, correct, this will return false. Okay, so we'll take some of the numbers. For example, I have taken some of the numbers from the test case which was given, and say, let's see. Oh, sorry. Yeah. So let's print this one. How this works? False, correct? Because this is not falling under this. Let's say 55. Let's say 55. Okay. Good. So 55 is also not giving us. So 55 is also worse. Let's say 56. Can 56 be expressed in some form? It should be, because white is giving us none. Let's see, 1 second. White is giving us none. Here. Okay. 56 it's giving us none. White is giving us none. It's giving here true. I think somewhere I have given a mistake. Sorry, it's L. Sorry, I have given us L instead of return. Sorry, my bad. It's return. Sorry. So if it is returning, yeah, it's returning true. correct? If any of this thing is not, it will be not else. So if is any of this range it is not true, n is not equal to m, then we can say that okay, it is true because it's not falling under this. And you can check for any number here, say 200, can it be? Let's see. It's true, so it's a 3 square number. What was the 71 was here? Let's see 71. Let's see. It's a false because it can. So this is our first question is done. Let's see for the second question. Write a function ref_free that takes input a string s and checks whether any character appears more than once, and the function should return true if there is no repetition or and false otherwise, correct? So it's a fairly easy code, I feel. So def of this part, so it will just see that if any character is getting repeated. Okay, so our referee is like this, our code. So we'll just first just make a list of characters. So character in s is equal to a list as an empty list, and we'll index through the list. So for I in s, if I not in car, so I am checking here that if I not in car means that if I is already there, we should not append I, because that means that will be a repetition, right? But if it is not, if it is there, we should not add is, right? Because it will be a repetition. But if it is not there, that means we should add the character there. So if I not in car, car dot append I, else if I in character, else it should be false. So else return false, false, right? Else return false. And if after characterizing all the character, if it is getting inside, then you should return true, because when all the character it's getting, and if it is not getting returned, it is not going here in the else, that means it's oh no, none of the character is getting repeated. So for so showing an example, let's say ref free, I'll give a string. So I'll say okay, my string is gf h g j k. So see, it should stop when it is 1G is already. So if I debug it, I give here a big breakpoint, and if I debug the cell, uh, yeah. So if I debug the cell, now S, what is our S? S is our, this one is our S. S is our GFHGJK, whatever it is. So we now creating a empty character like this, and we are saying okay, first I is our G, correct? So first I is our G and G is not there, sure, so it will append. Next I is our F, it will also append. So now see, it's a list GFG. Okay, it's also appending. Now what is I? I is G, so it should not append, right? So it will go and it will return false, and then return from the function like that. That's it. So it returned the function as false. I should give here a print statement, otherwise it will not print the true or false. If I run this with flaws, if I removed this G, you can see it will give me true. It's giving me true. Okay, so this is a fairly simple question. Okay, and let's see for the last question for the day. Yeah. So a list of numbers is said to be in a heel if it consists of an ascending sequence followed by a descending sequence. So if the number is followed, so yeah, ascending sequence followed by, so if my number is like say 5 7, and then it is like 6, sorry, 5 happened 5 comma 7 comma 6 comma 2. So it's like first it is rising like this, so 5 7, then it is going 6 2. But if I give it like 6 9, then it's 5 7 6 again 9. So, or if we give, then what is the other option where each of the sequence of length is at least 2? Yeah, of course it actually should be 2 5 7, correct. Similarly, a list of numbers is said to be a valley if it consists of a descending number of sequence. So for example, if I have 7 followed by an ascending sequence, so for example 7 5 then 8 10, it is again like going like this, 7 5 8 10. So it is a quadrant valley. Okay, so yeah, and we'll assume that we don't have a something like this 5 7 7 9. If it is something like this, we are assuming that our code doesn't need to see if it is equal. So if write a Python function, function heal valley L, that takes a list of integers and returns true if it is a heel or a valley, and false any otherwise. So if it is a hill like this, it should give true. If it is hill like, if it is a valley, it should give like this. If it is like hill, it should also give false. If it is like valley hill, it should give false. If it is like valley hill valley like that, it should give us false. Okay, so how it will work? So um, so def hill valley L, and we'll have a list inside the hill valley. So we'll say that for I in L, correct? For I in, sorry, for I in, it will be L, or no, sorry, it will be for I in range of len of L, correct? So we are making a range from 0 to len of L with one step size. We'll say that if now how we'll see a valley, the value will be so it should be always like either this, or it should be always like this, correct. So it should be always go up, or it should always go down. Okay, so I'll say okay, if it is in an increasing order, so if, or rather I'll do in a different way. So I'll create two variables, heel count and valley count, equals to, at first they both are 0 0, correct. I will say that if L I L I is my L I, yeah, L I to L I minus, sorry, it would be L I is greater than L of I minus 1 if L of I minus 1 is less than L of I, and here I should give actually 1, because otherwise it will create again it, because at position 0 there is no 0 minus 1, correct. So L of I minus 1 is L of minus 1, that would go to the last number, correct. So I should always give 1. From 1 it should start, correct. Of I minus 1, then I should say, okay, make HC plus 1, sorry, HC plus equal to 1, okay, correct. L if sorry L if I L, the opposite thing, L of I minus 1 is greater than L of I plus 1. L of I minus 1 is greater than I plus 1. Oh, sorry, sorry, L I, and I should go from L of I, right? 0, 1, 2, 3, 4. Yeah, len of I plus 1 I should go, uh, because here len of L means, if len of L is 5, so the range will be 0, 1, 2, 3, 4. No, actually, yeah, it should be 1 only, because the index goes like, if my number is, say, this is my string, sorry, my number of list of numbers like 1 comma 5 comma 6 comma 8. No, actually the heat. Okay, I have to, one more thing I have to check. So 1 comma 5 comma 6 comma 8. Then my index should go 0, 1, 2, 3, 4. So it should go len of, so but len of this 0, 1, 2, 3. But len of this S is, yeah. So I should go here. Actually, it should be also less than L of I plus 1. Correct? If I'm going from L to L of I plus 1, then only till I can stay. So here also I should now L of I, if when L is equal to here 0, 1, 2, 3, when I is equal to 4, 3, then 3 plus 1 will give me error because L4 doesn't exist. So here also I should go till only minus 1, correct? So I'll say that, okay, hill count is equal to 1, and if the opposite is there, L of I plus, sorry, I plus 1. If opposite is there, then it should be a valley. So valley count will be plus equal, sorry, plus plus equal plus plus equal to 1, correct? Okay, now I'll just count how many hill valleys are there. Now my only truth is that now I'm counting is okay. So I'll first count and I'll get some hill and valley count. Okay, now we'll say that, okay, there should be either one hill or one valley. There can't be two hill, two valleys, two hill, one valleys, like that. Okay, so if HC equals to 1 and VC, sorry, HC equals to 1 and VC equal to 0, then my list has only one hill. I'll say, okay, now me return me true. If HC equals to 0 and VC equals to 1, means that has one value, then also return me true. Else, in any other case, else return me false. Okay, or rather I actually can decrease it a bit. So if HC, I can decrease it actually one level less, equals to 1, because both the case, then return me true, else return false. If HC plus BC is equal to anything else, return me false. Okay, and that's how it should work. So I have uh, some of the test cases from the already I've made already, which I'll just write it here. Let's see. Okay, so this program 1 2 3 5, it is a up slope. 4 3 2 1, it's a down slope. Okay, so it should be a hill, right? 1 2 3, it's getting up and it's getting hill. Okay, so let's see, it should give me a hill count, correct? Okay, let's see what is happening here. Yeah, actually, if I think it little different way, yeah, so this may not be a valley, right? It may not be a hill. So hill should be, so this is also less than, so hill should not be like this, right? This, but this, yeah, so this should be actually opposite, right? The reason, I'll tell you, 1 second. So the reason is, when it's a hill is like it's going like this should also increase and this should decrease, correct? So this part should be the highest, correct? The middle portion should be the highest. In valley, the middle Li should be the lowest. So this should decrease and this should increase. So in this case, when it is considering 1 and 2, so 1 is here and I'm considering it from 1. So 1 minus 1, so it's considering when is 2. So when is considering 2, 1 is greater than 2, but 3 is also greater than 2. So if it will going only up, then when it is considering, then after it's considering 3 is greater than 2, good, it's going upwards, but 5 is also greater than 3, so it is also again going upwards. But when it's continuing 4, okay, 5 is greater than 5 is sorry, it's continuing 5, 5 is greater than 3, but 4 is less than 5, so 5 is now touching a maxima, so like this. Then it's considering 4, so again it is going down, so 5 is less than, sorry, 4 is less than 5, and it is greater than 3, so again it is going down like this. But when you see this function 1 2 3 4 5 3 2 4, here 1 2 3 is going up, correct? 4 till 5, till 5 it is going up, fine. 3 2, till 3 2 it is going down again, good, there is a one heel. But after 2 it is again going up like this, then again going down, so there will be two valleys, correct? So let's do the debugging and we can see the results more clearly. Okay, and I'll also have to create a breakpoint here, otherwise it will not go to the function. So we'll say, okay, debug cell, we'll go, okay, next. Okay, so now the HC, and okay, I'll clear all the variables here, otherwise it will be confusing. Sorry, I have to stop it. Good luck, variables are clear. I'll once more, I'll debug. Let's see. Yeah, So now my list is 1 2 3 4 5, whatever my L, and my heel count or value count is 0. Now for I in range of 1, so first I will be 1, I minus 1. So what will be I? L of I minus 1 will be, it should be, show me 0, oh sorry, 1. L of I minus 1 is basically, okay, first what is I is 1, correct? Here the I is 1. So L of I minus 1 should be as 1. Ignore this thing, okay, this is something else, ignore this part. 1, and what is L of I plus 1? I plus 1. Okay, let's see, it's 3. Okay, and L of I is of course will be 2. Sorry, L of I will be 2. L of I will be equals 2. So now, so if this condition is this the condition holds, we'll see what this condition says. To be false, yeah, it's false. So HC won't be plus equal to 1. Do the other condition also holds? I don't think this also holds, because you can see that 1 is greater than 1, 1 is less than 2, less than 3. Also false. It will not go. When is coming next is coming 2. Again, it is not holding. Coming 3, again not holding, and it's coming then 5. So at 5, I think this condition holds, right? Okay. I think this condition holds, right? Let's see. Yeah. Oh, 5, 3 is less than. Okay, what is now I? Oh, we have crossed the 3. So I think HC has already got 1. Oops, we have passed 5 already. That is now 4. It is not holding. This also not holding, so will not see anything, correct? Now, so it will return me a true, and oops, this is doesn't need, just function is calling, and let's see the next one. Okay, we'll debug it again. I'm seeing the, I don't need it here. Next function. Okay, when I'm debugging it, first h is equal to 0, first I is equal to 1, and this L of I minus 1 I, this sorry, doesn't hold, also doesn't hold. So we'll see when it is coming at 1 2 3 4 5. So let's see, let's wait for I. Okay, I'll give a breakpoint here rather. Let's see, 3 4 and 5. At 5 this condition I think holds true. Let's see, 5, at 5 it's okay. I is equal to 5. Okay, so 0 1 2 3 4. Actually, so I should have taken 0 1 2 3 4. So when it was 4, that time I should have taken. I'll just re-debug it once again. I'll stop this. Yep. I should re-debug. Actually, I should be equal to 4. And considering I here, I is the position here, right? So at the first one, when I is equal to 1 2 3 4, then when I is equal to 4, we should stop. 1 2 0 1 2 3. So I is equal to 3. Now I is equal to what? L of I is equal to now 5. I'm writing here instead of here. So now L of I is equal to 5, correct? So now this condition should hold true. That's what it's holding, and it's giving h equal to 5. Again, it will never will tell it is true, so we'll proceed to our next function. Yeah, now I'll give again a breakpoint here, and let's see. Yeah, so when we'll stop here, when 0 1 2 3 4. So when I is equal to 4, we'll stop. Okay, 1 2 3 4. So at 4, this condition holds true. No, it's not holding true, right? Oh, we have again stopped in the next position. Whoops. Anyway, you know that this is cut class 1. We'll again stop at 0, 1, 2, 3, 4, 5, 6. Correct? So we'll stop at this position when L of I is equal to 2. So what we can do here, I'll just show you one thing. This is an interesting thing. We'll give a conditional breakpoint. We'll say uh, okay, we'll say here we'll give a conditional breakpoint. We'll say okay, at this condition we'll stop it at L of I equals to 0, 1, 2, 3, 4, 5, 3, 2. So again this is a value. We'll say okay, when it is a value, stop it. And let's see what this does. Will it stop here? Yeah, it stops. So LSI equal to 6. 1, 2, 3, 4, 5, 6. Sorry, 0, 1, 2, 3, 4, 5, 6. This condition doesn't hold true. This condition should hold true and value is equal to 1. Correct? Now it will not stop. Let's say I'll just stop it here then. Yeah, correct. I'll stop it here and it says that okay, HC plus VC equal to 1. No, HC plus VC equal to 2. There is 2 hill, 1 valley. There is one more hill here. Correct? Because if I take the 5, 2 through 5, then again there is a hill. 2 for 5 is a hill. 5 is again, 2 is a valley, then 5 is again a hill and it's going down. Like that, it should return me false. Yeah, and that's how it is done. Okay. Yeah, so if I now print all of them, it should give me true, false, 4 minus 1. That should give me 954, 1, 2, 3, 7. This is a valley, right? It's only going down then going up, right? Valley, like this. It's a valley. It should go. It should give me true. So it's true, false, true, and this is what 5, 4, 3, 2, 1, 0. So it's only going down. It's just a negative slope. It's not a value. It's just a slope, negative slope. So it should give me false. So it should be true, false, true, false, true, false, true, false. Okay. So yeah. So I think this. I hope this will help you solving your own assignments that you have now. And we'll again meet on next Tuesday, that will be 16th August. So till then, goodbye. Take care of yourself. Thank you very much for watching.